Okay, I'm gonna do worksheet 5A. I'm not gonna do B because it's pretty much the same idea. Question 1. You have this function in terms of x and y, and it's x squared, y cubed, 5x, y squared. You're asked to find the derivative with respect to x, they also call it fx, and the derivative with respect to y, they also call it fy. So if you do the derivative for this with respect to x, you treat y as a constant. So that's a constant, and the derivative of x squared is 2x. So you go, it's 2x and a constant. The derivative of this with respect to x, so now 5y squared is a constant. And as you know, a constant in front of x would be just a constant. Another way that I like to do this is just to simplify the process of why this is the answer. You can look at it as this. So when you do it with respect to x, y cubed becomes a constant. So anything other than, so you're doing it with respect to x. Anything other than x, give it a name. So y cubed, I'm gonna call it a. And 5y squared, I'm gonna call it a b. So if I find the derivative of this, it would be 2ax plus b. And a is y cubed, b is 5y squared, so I put them back. So it would be 2y cubed x, 5y squared. That's another way of looking at it, if you're not good with this. I'll try both ways when we find the derivative of the second one with respect to y. So, x becomes a constant, 3 down, 3x squared, y squared. 5x is a constant, so you do down. 2 is times 5x is 10x, y. If you want to do it in a different way, again, you're doing it with respect to y. Anything other than y, call it something else. So here, x squared, I'm going to call a, and 5x, I'm going to call b. So I'm only leaving the ones that, the terms that actually have y. So this becomes ay cubed, by squared. Find the derivative, 3ay squared, 2by, put this back, 3x squared, y squared, 2 times this would be 10x, y, same answer. So, this is the answer for the first question. Question 2. You have this function here, question 2, a function in terms of x and y, and it's ln x squared plus 3y squared. Find the derivative with respect to x. Find the derivative with respect to y. The derivative of this with respect to x, and in ln, you know the derivative of the ln, you put it in the bottom. And the top would be the derivative of the inside. And with respect to x, it's basically 2x. The derivative with respect to y. It's a ln, so 1, you put the inside in the bottom, top derivative of the inside. So this is the first two questions. Question 3. You're given in question 3 a function in terms of xy, and it's e to the xy minus y squared. And there is a vector 12, negative 5, and you have a point P of 2, 2. And you're asked for the rate of change. Well, when they ask for rate of change, they're asking for the derivative. So, and then they tell you A, B, C, D in the different directions. To do this, we have to do something called gradient. I'm just going to write it down. We're going to do a gradient. Gradient, it's called the derivative of the rate of change. You find the derivative with respect to x and the derivative with respect to y. It's a vector, so we have to indicate it's a vector. Derivative of this with respect to x, any e is itself times the derivative of the top. With respect to x, xy has the derivative of y, minus y squared doesn't have a derivative. Derivative of this with respect to y would be itself. Derivative of the top with respect to y, yx has the derivative of x, and y squared derivative 2y. That's the derivative. That's the gradient. Now, what's the gradient at the point 2, 2? You plug 2, it would be e, 2 times 2 is 4, and 2 squared is 4, times y, which is 2. 2 times 2 is 4, and 2 squared is 4. 2 here will give you 2, and 2 times 2. This is e to the 0. E to the 0 is 1. 1 times anything would be just 2. This is 1, and 2 minus 4 is minus 2. So now we know that this is your gradient. So now remember, I'll write it down here. The gradient of xy at the point 2, 2 equals the vector 2 and minus 2. Or you can write it as 2i minus 2j. Once you do this, they tell you in A find this rate of change in the direction v, in the direction of this vector. First of all, we need to find the unit vector. The unit vector of this, you take it over the magnitude. So it would be 12 and minus 5. The magnitude would be the square root of this number squared and this number squared. Square root. So you get a unit vector of 144 plus 25 is 169. Square root of 13, so this is 12 over 13 minus 5 over 13. If you want the gradient in this direction, you just multiply them. Dot product. So 2n minus 2 times 12 over 13 minus 5 over 13. First times first, 2 times 12 is 24 over 13, and plus 10 over 13 has 24 over 13. That's the answer for the first one. For the second one, in the direction of largest increase. Largest increase, you find the magnitude of this at the 0.22. And if they want the minimum, it's minus the absolute. So the magnitude in this case would be square root of, you take this number squared plus this number squared. 4 plus 4 is the square root of 8. Okay, part C. In the direction that makes pi over 3 with the x-axis. So we need with an angle. To do this with an angle, the vector would be cosine of whatever this angle is, sine whatever the angle is. So cosine pi over 3, the sine of pi over 3. Pi over 3 is 60 degrees. Cosine of 60 degrees is half, and sine would be root 3 over 2. And then you do what we did with the first one. The product of this with the 2 and minus 2. First time first, 2 times half is 1, and this time this would be minus root 3. This is the end of the first part. I'll continue with this in the next part.